In today's video, we're going to take a look at another challenge that will use the wall maze, but this time we're going to use the distance sensor. And the distance sensor, you can see this is what the virtual robot would look like, is on the front and center of the robot. And the way it works, you can see down here, it would, if this was an actual distance sensor, would send out a sound wave, an ultrasonic wave, bounce it off, and measure how long it takes for the sound wave to go from the sensor out to the object and back. Obviously, the longer the object would be. And it can tell the robot in millimeters or inches just how far away that object might be. So again, we're working on the distance sensor, and we're going to be using that distance sensor to navigate the maze again. So to give you an idea or a better idea of how the distance sensor will work, let's compare it to the touch sensor that we were using. Here you can see your robot, and it's inside the wall maze that we used. And here you can see a sample program that would use the touch sensor. And in particular, there's the left bumper pressed. So wait until left bumper pressed, and it's going to drive forward, wait till the bumper gets hit, and then continue on and do what's next, which is turning left. So let's just watch that. The robot's going forward, it hits the wall, then it turns, drives forward, hits the wall, then turns. So with this sensor, you need to run into the wall in order for the sensor to work, and in order for the sensor to detect that there is in fact a wall there. But let's take a look at an alternative. Over here, we have a slightly different set of code, and we're going to take the when start, put it on top of that. What's the difference? The difference is that in the one that we just used, we waited until the left bumper was pressed. Let's look at the wait until here. This time we are waiting until front distance in millimeter is less than 100. So what's going on is the front distance sensor is checking how far away the closest object is. Once we get less than 100 millimeters away, then we're going to do whatever's next, which in this case is turn left. So in this case, we have the front distance less than 150. Let's see what happens with the robot. Notice it did not touch the wall before turning. Watch the next turn. It turns before the wall. So the distance sensor can detect the object before the object is contact. Let's briefly talk about the code that makes this work. As I said earlier, it's all about the wait until. And so, whereas before we were waiting until the left bumper was pressed, now we are waiting until front distance in millimeters is less than, and this number can change. You can adjust this on your own depending on what works best. I found that 150 seems to be pretty good. So in order to find this code or use this code, it's actually two different things. First, you're going to have to go and find this hexagonal shaped piece of code, 0 less than 150. And then you're going to need to take this sort of aqua colored object and place that into the 0. Okay, and I'm going to let you find those, but here's a hint. This one's green. This one's like this, like I said, sort of light blue colored. But put that in 0, and you put the whole thing into hexagon, and that's what the code should look like. And once you get that basic idea, it's going to work pretty well. One last thing that I added so that A, you could see better, but B, you can control the distance sensor does not work as reliably as the touch sensor. And if you go too fast, it might not notice that it has gotten closer than 150, and it might run into walls, it might mess up. So in order to adjust for that, I slowed the robot down with this piece of code right here. At the very beginning, right after we started, you could change set velocity. Of course, you could change it again and again, but once I change it once, it's going to stay at that velocity until I change it again. So I set it to 10%. And 10% didn't really seem like 10% the actual full velocity, but it went slow enough. 25% and 50% did not seem slow enough. So that's under drive, and it's, let's see, set drive velocity down here. So you can do that and change your velocity if that helps your robot be a little bit more reliable by slowing it down. That's kind of what it looks like.